This webinar will also include demonstration by other and practical use cases as well. So I am pleased to hand over to Christian. Christian, over to you now.
Yeah, thank you, Syed, for the nice introduction. Also, a warm welcome from my side, from Germany. So we have early morning, and I guess you are, yeah, almost close to the evening. So I now like to present um, our topic of today. So the topic for this webinar is Analyzer. This is the name of the MMP software, and it's Advanced Noise Vibration Harshness Software Solutions for NI-DAQ hardware. I'm very pleased here with TME. We worked together for a very long time, and this is, let's say, what we talk about. It's an intelligent software. The MMP analyzer enables engineers to gain a detailed understanding of the dynamic behavior of the product. So it's a versatile tool designed for data acquisition and analysis. It's as a dynamic signal analyzer, it allows the engineers to examine and to understand dynamic signals with precision. And one of its key features is its seamless integration as a linking component for vibration testing. Engineers benefit from the extensive analysis functions. We will go here now in step by step, so you get a good overview of this intelligent software that works together with NI hardware and also with other hardware. Um, Here a short overview in the markets. We are selling our analyzer. So you look at aerospace, automotive, defense, railway, research, rotating machinery, test houses, heavy duty machinery, and of course also other markets. Um, I don't want to show all the references, but here just a few. Many customers are in the aerospace market, such as NASA in the US with really several sites. We have Boeing, we have Lockheed Martin, we got SpaceX, we have DLR Germany, Airbus Defense and Space in Germany and France, and we have systems in India in the ISRO organization or in Korea with the Korean Aerospace Research Institute. So there are many, many applications for the MNP analyzer software. Um, So we really go in many directions. You can see the analyzer also as a Swiss knife. So it has many, many tools like a scissor, like a knife, um, many things. So Syed already mentioned it. So we can measure all these transducer types coming from temperature, voltage, stress, strain, pressure, force, acceleration. This is the majority of the applications, so that you use an accelerometer or a microphone. Um, and the analyzer applications you see right-hand side. So structural analysis, rotate, dynamic signal analysis, time, frequency domain, vibration testing. So we have a lot of customers that are using shakers for vibration testing, for environmental mechanical testing, and in combination of that, there are additional channels required for sign testing, for random testing, for shock testing, and this is then acquired with the analyzer. Acoustic analysis, I come later to this. Calibration you can also calibrate your impact hammer, for example, or your microphone, and it's also good for data monitoring. Um, the analyzer is having a lot of graphical features. Arthur will present in a live demo after my presentation so that you get a closer look how the software looks and feels. Um, just one thing here, the analyzer is supporting things like ActiveX. So you see here I'm in a PowerPoint presentation, and you can have the same functionality that you have in the analyzer here in a PowerPoint. For example, You can add a second cursor. Yeah, you see then the difference here. I'm calculating RMS values between these curves. You can highlight the curves. You can, oops, this was too fast. Yeah, you can scale, and it also works for um, mode shapes. Yeah, so if we look, let's say, like operating deflection shapes, or we go into modal applications, um, or we go in OMA, operational model. So what you see, I can really do and work here with, let's say, this one here is mode 1. It's a polyfrequency analysis. Yeah, and you can simply look here into different angles. This is all possible. If you like, you can also add the measurement points that we have. You can make it a little bit larger from the deflections. You can see it in color. So all this stuff is available. Yeah, we also go in rotating machinery applications. So what you need here, of course, for rotate is the tacho signal. Yeah, with the tacho signal, we can create these 3D plots, these Campbell diagrams. So you can look from the top, or you look from the side. So we have the frequency domain on the x-axis. We have the amplitude on the y-axis, and on the z-axis, you see the RPMs over time. Yeah. So this is the typical run-up of an engine, of a machine, what you see here. And you see that the first mode here in red color is having maximum amplitude. And then you see the corresponding frequency. You can create order cuts out of these 3D plots. So then you see individually the frequency, the amplitude, and the RPM related to that. Right. A little bit more on NVH structural analysis. So here is a photo of an impact hammer. So there are various applications where we just go in ODS. So we always need to measure a frequency response function, an FRF. So an FRF is the combination of the force which we get by the hammer, by the impact hammer, and then we need to have an accelerometer which gives us the acceleration response, and the combination of the acceleration divided by force gives us the frequency response function. And based on that, with the geometry creation, which can also come from a CAD file, like an STL file, for example, we are able to create and to estimate the mode shapes. We want to have mode shapes. We want to know the natural frequency, and we want to know the damping, which goes into FE software. Right. Acoustic analysis, also one of the major topics we address. So coming from, let's say, sound intensity or sound power measurements. So we are compliant with some ISO standards, which you see here, like 3744 or 3745. Yeah, and of course, many applications are just in octave band. So we have a third, a sixth, 12, 24 octave analysis. And also you can make a calibration on microphones, for example. Right. Yeah, rotating analysis, we already had this topic. So you need to have a tacho signal. Here's a photo of a motor saw manufacturer. So we are happy to have these Swedish Husqvarna company, as well as the German Stihl company, being in motor saw. So this is a very nice test article where you have a lot of vibrations, also human vibrations. Yeah, and there's also shaker testing here is involved. So this is really nice test article example. Um, Let us have a look on the supported hardware. So, as you know, the topic of this webinar is analyzer with the National Instruments hardware. And what you see here is the diversity of the National Instruments hardware, like you got compact DAQ chassis with several of these modules. You got PCI modules. So PCI modules were just or are just inserted into your desktop or your power PC. You got USB devices, and the National Instruments hardware is, of course, coming with the software laboratory virtual instrumentation engineering workbench, um, which is a very good tool, also a graphical tool to make a lot of easy, let's say, programming tasks when you want to do measurements. So many users are in favor of the LabVIEW software, which is fine, there's no question. But when it really goes into some levels for advanced applications like model analysis, um, as an example, it really becomes difficult or nearly impossible to create such an application with the LabVIEW software. So you will easily see that there are limits, and it's also our customers like to have a professional software which is tested for for many applications. We are in this market with the analyzer for more than 30 years. So you see there's a lot of experience and also a lot of security for the software and reliability of the software. So in one word, LabVIEW is okay, but when it comes to advanced features, you should go with an intelligent software like the MMP analyzer. Yeah, so we provide a ready-to-use integrated solution, and this addresses the complexity and time investment, yeah, which is yeah, associated with NI's programming um, hardware platform. Let us look into what is required. So you have NI hardware or you intend to purchase NI hardware. TME is also a listed NI partner for the hardware. So what is really needed? So what you need first of all is of course the NI-DAQ MX software. So this is the basic software, core software to run NI, and on based on this you also got let's say test panels, functional test panels. So this is the basis. So you must install, you must have a runnable device on NI. So then we just hook up on this application. So you have to install the software, and what you see then, you install the analyzer. You then go into the hardware selector, which you see here right-hand side. Just take my little laser pointer here, right-hand side. So you just click on third-party devices like National Instruments. And then you will also see in our user interface here in the channel configuration, right-hand side, the module that we found. Yeah, so in this example, it's NI-9233. This is one of the compact DAQ modules. And of course, we offer you to get a free 30 days analyzer trial license. Yeah, so when you have NI hardware, it's really good. If you don't have NI hardware, you can also do a lot of things. We got user examples for the analyzer software. And there are two ways to get this 30-day trial software. So either you go to our homepage and request a license, or you simply contact our TME partner, and the TME will contact us. We will give software to install, and at the end of the installation, you have to give us a soft code. So this is called get soft code. We get this code, and we will return with this soft code, enabling you to work and operate with the analyzer. Right. Also on top of that, we have a free of charge analyzer viewer. It's limited functions, the analyzer viewer, but you can do some things. You can also import free file formats like universal file. Yeah, so can also use this free of charge analyzer viewer. You can download it from our homepage. Um, let's go more in detail about the National Instruments hardware. So you see these are the modules for that we support on PCI, PXI, PXI Express, USB. These are the modules that we support in dynamic signal analysis, generally speaking. So you see the cases, vibration analysis, acoustic measurements, IEPE sensors. We also support TEDS, transducer electronic data sheet, so that we can read in sensor information like sensitivity model, when was it calibrated in the software. You got multi-function data acquisition here with these module families 622X and so on. So you see the cases, general voltage measurements, digital I/O, test bench data acquisition. Yeah, so here two examples. I continue here with the DSA, like all these modules that we have in PCI, PXI. Yeah, 4474 is a 4-channel module. 4472 is a 8-channel module. You see USB modules here. And from my experience and from the customer base that we have, this model NI-9234 is the most used model what I see with our software. So it's a 4-channel input module. You can run it just with a USB carrier, so you don't need a power supply. You just power it via an USB cable, or you house it in a compact DAQ chassis. So it has 4 inputs, 51 kilohertz. It supports voltage and IEP, so you can adjust this, and it has a 5-volt input range, which is ideal for all IEPE accelerometers, which have a 5-volt range. Um, right. Right-hand side, you see all these multi-function data acquisition modules, yeah, PCI, PXI, and so on. Yeah, continuing, so you see, of course, signal sources are supported as well by the analyzer software. So the basic example for this is the modal analysis, experimental modal analysis. So you know we either excite with an impact hammer, so then you don't need a source. But when you have a shaker, you want to do a modal test with a shaker or with 2 shakers, then you need a source signal. So digital to analog converter DAQ output, where we then have excitation modes like sine or burst. Burst random is the main excitation mode in modal analysis. So therefore, these signal sources are supported. When it comes to rotate, as mentioned earlier, we also need counter tachometer inputs. Yeah, so we need to measure the tacho input, which can come from a laser tacho, or you got to tape something like this. So counter tachometer are required for doing rotating machinery applications. Um, right. Um, Apart from the National Instruments hardware platform, we do support also hardware from PCB and the model shop. So this is hardware that is completely digital. So that means you don't need a data acquisition unit. So you just combine the sensor, which is coming with a USB connector. You just link this to your computer, and then you are able to make measurements. So it's also, there are 2-channel devices also possible. So these devices also support, or they are ICP sensors. Yeah, so we supply a constant current to these ICP sensors with a computer, not with the data acquisition unit. And for simple application, this might be the right choice. Yeah. Um, as a manufacturer in the data acquisition field, or generally speaking, noise, vibration, harshness applications, we of course have our own proprietary hardware. So what you see here is the pilot Ethernet. So it has an Ethernet connector as well as a USB interface. You can have it either with 4 input channels or with 8 input channels. It comes standard with 2 sources, so you can run 2 model shakers at the same time. And it also comes with Tahoe inputs already integrated, already on the instrument. It's a very compact design, so it's nice and sexy. We have a digital input output at the rear. You can power it with 9-volt DC, or you just take the delivered power supply. We can also combine up to 4 8-channel units to 32 input channels, and then the hardware is daisy chained here by clock in and clock out and synchronized by this way. Maximum sample frequency is 204.8 kilohertz, and it's running on 24 bits. If you need more channels, we can also supply the WebRunner. WebRunner is a hardware platform. This is not used for mobile application. It's more for stationary applications. So we have AD modules with 102 and 204.8 kilohertz, as well as bridge modules for strain gauge applications or source modules for running shaker applications. Right. If we now come to the licensing, application licensing, I think I need to hurry up a little bit. This is the licensing structure that we provide. So we start with the structural, yeah, so ODS, MDOF, OMA, all this is with the structural solution. You can extend, this is the MDOF, multi-degree of freedom. So we have curve fitters in time and frequency domain. You can also just go with ODS, operating deflection shapes. We can have multiple sources, meaning at least you have 2 shakers for the excitation. We can calculate mass properties out of model, and we also are in nonlinear topics like these Hilbert-Huang transformation. Coming to acoustics, so simple thing is the acoustic here in the nth octave, 3rd octave, 6th octave, sound intensity, sound quality, sound power. A special solution you can also have with us is the impedance tube. So if you're interested in impedance tube testing, we have a complete solution. We can also supply this as a complete turnkey solution. So including the tube, including the microphones, including the speaker for excitation. Third example is the rotating machinery market. So I'll already show these Kempel diagrams, order cuts. All this is in the rotating machinery package. Based on this, on top, we can do balancing, 1D balancing, 2D balancing, and we also have an orbit analysis on shafts. This is an offline analysis. Right. Then we have special applications. So you can go, for example, in a stepped sine shaker excitation. If you have shakers for mechanical vibration testing, you can do sine data reduction, so adding additional channels. We have shock response spectrum. We have shock capture, that's for shock machines. And we can also do an survey on your shaker. So how good is the performance? Do you need maintenance for your shaker? And on top of that, we have application programming interfaces. So you can run remote control the analyzer user interface. If you don't want to work with, let's say, measurements on data acquisition, We also have the e-reporter licensing, where you just can create nice reports, analysis with the e-reporter. Yeah, structural, acoustic, rotate, and also specials like reading long time history files and then post-process with the e-reporter. The licensing is available. Usually, it's coming with a USB dongle. Yeah, so wherever you install the software in combination with the dongle, it works. We can also give a license key, so a soft code like we will do with your trial license. And optionally, we also have, let's say, server licensing. So for universities, so if you have several applications in a mechanical university department, so many students work with the software, so we can go with this network-based license. So it's floating or it's also detachable. Very important, M&P licensing is permanent. It's perpetual licensing. Yeah, so once you have it, you keep it for lifetime. Right. Thanks for your attention. This was my introduction presentation. And I now like to hand over to my colleague Arthur, who will give you a nice live presentation. Arthur, stage is yours.
Okay, thank you. Can you hear me? Yes?
Yes.
Yeah, okay. So hello everyone. Now it's my part. I will give you a short live demo of our analyzer. And as already mentioned, the analyzer is a modular measurement software designed for general measurements or various vibration and acoustic applications such as experimental modal analysis. And during this demo, I will first guide you through the user interface, the project structure, and then I will show you how to create a simple measurement, how to create a setup for a measurement, and then I will show you the possibilities of how to analyze the data both online and after the measurement. And in the last, at last, I will show you a brief overview of the integrated experimental modal analysis. So let me share my screen. So I hope you can see it right now. Yes?
Yes.
Okay. So let's start with the user interface and the project structure. As you can see, the user interface is clearly organized. Everything we need is available on this main window. At the top, we have here a quick access bar, a toolbar, which allows you to create a new project, to open an existing project, to save this project, or to start the measurement, stop the measurement. You have here access to useful tools like the measurement calculator or a reporting tool. And here on the left, you have you can add different charts for your measurement. So it's very easy. We have a 2D chart, we have a multi-chart. So depending on your application, you can create an individual layout and you can save several layouts in the project and load them later by double click. So we have here multi-charts, 3D charts for rotate analysis, for example, or even we have a map here. So if you have a GPS module, you connect it to your PC, you can link the GPS location to your measurements. This is also possible. So, for example, you can, for a measurement, activate a time window record and a chart for your spectrum. So depending on your settings later. At the bottom, you have this project browser. Here the measurements are stored later and you can open the measurements later here. And also different setups and layouts can be loaded here by double click. So let's start with a simple measurement. I will show you how to create a setup. And for this demo, I have connected here, you can see a USB NI hardware 9162, and I have connected it to a signal generator. So it's connected via USB with my PC. So you will see live data. So setting up a measurement is quite easy. You start with the configuration button here, and you are guided through all relevant setup steps. So now you can see this window has opened, and in the first step, you decide what kind of application, what kind of measurement you want to run. So you can select here an impact measurement for modal analysis, acoustic measurements, and depending on the selections, the steps will change. For example, if I select this one, so the software change the setup for the setup step for your application. So you can go directly to one of the tabs, or you can go to step by step to the next point. So now I go to the transducer configuration. We can select here the type of the measurement. We want to measure the response. If you have, for example, impact analysis, you need to select excitation channel. So if you want to measure transfer function, but in this case, we only need the response. You can enter a name for your measurement signal. You can select different units. With the right mouse click, you see all available units here. You have to enter here the sensitivity. And if you have connected an IEPE transducer, you can activate the supply here and change the coupling here. And you can enter the sensitivities and the model name here manually, or you can use our database. You can create a database for all of your transducers and load it by double click, like here. Let me change my settings again. So, and here you can see the connected hardware. It's a NI-9233. So now if I have made the setup for my transducers, I go to the next step, and here I can select the measurement range or directly the sample rate, and I select the block size, which result in frequency resolution or a block time. I select here the measurement time and some other settings, and you can also add trigger channels here if you want to trigger a measurement by adding the trigger channels. So let me check my settings. Okay, so in the next step, so we record time data, and in the next step, I select how I want to process my time data. For example, I want to create a FFT. So I select the spectrum. I have here some more options, but I will go to the next step. In the next step, you decide what you want to store in your project. You can see the time signal, for example, and some other functions, but here you select what you want really to store in your project. So, and for example, RMS time history, and you can even create virtual channels by adding 2 channels or create an average of several channels. This is possible as well. So now I have created a setup. So I can create several setups in one project, and I can save them and load them later here by double click. So if it's required. So now I can one what I want to add. So this is the minimum settings you have to enter for your measurement, but of course we have some more settings. And for advanced settings, you can, for example, add filters or resample your data, or automate your measurements. You can run your measurement in specific intervals. So you have a lot of options, but you can reduce it if you don't need it. So you are not overloaded with the settings. So now you will see already the live signal from my signal generator, and he activated the time record, and you can see channel 1, channel 2, 3, 4. You can also activate all channels in one chart, of course. And here you can see the time history, for example, or the RMS time history, spectrum, and here the same. You activate the 4 channels. Yeah. So now I'm not recording. I just see the time data and the spectrum online. If I'm ready with it, I can start the recording. So during the online measurement, you can already analyze your data. You can check, is everything fine? You can create cursors here. You can see the values here. You can move the cursor to the max, for example, and see directly the maximum values. And in the bottom here, you see the status of your measurement. The number of blocks we have measured, the status of your measurement, like here, for example, we are waiting for the record action, and you see the overload of your channels. If you don't need it, you can just deactivate it. So you have more space for your data. So let's record the data by clicking on the record button. You can see now we are recording the entered blocks or the entered time in my settings. And during the measurement, of course, we have a lot of options with the calculator. You could, for example, create an octave analysis of your data. You can integrate your data or make an differentiation in the frequency domain. So we measure the we measure the voltage. But if you, for example, if you measure an acceleration, you can calculate directly the velocity and the displacement by integration or differentiation. If you go to the properties value, you can activate, for example, the maximum value of your 4 signals as in this pop-up window or in the legend or as a label. So let's stop the measurement. So the measurements are now stored in the workspace here. with the name I have entered. So demo was entered here, and we have added a timestamp. If we start a second measurement, you will find a second workspace in your project browser. So here now you have 2 folders, 2 projects. If you group it by function type, you can easy drag and drop it to your chart. You can do it by double click. You can select all of your measurements and paste it in the chart. You can zoom in here. You can move the chart by pressing the control key on the keyboard. So you have a lot of options. So if you are analyzing your data, as I shown before, you have this value table. For example, you can also calculate the damping or the RMS band and show it here in the pop-up window. You can copy the results and paste it to Excel. You can also copy the data from your chart. So you can make a quick export this way, but you can also export your measurements, your workspace in different formats like ATFX, MATLAB file, or universal file, the most common, or text file. And also the other way around, you could import data to your project from a third party. So this is what we can support. So ANSYS, ATFX, universal file, wave files, so a lot of options you have here. So if you want to create a reporting, you can copy the chart, for example, paste it here in Excel or PowerPoint for quick reporting, but you can also use our reporting tool here. You can create different templates and different layouts for your reporting, and you can export your measurements as a PDF file or as Word file. So you can select everything you need here and create a report. Yes. So this was a short introduction how to create a setup and how to make some analysis, general analysis. And now I will show you how to make some advanced analysis. Like the modal analysis, this is one of our key features in the software, but we have also a lot of other analysis options. Here, if you go here on this options, we have structural solutions, we have rotate solutions, we have data reduction solutions. We have a lot of other tools and applications we are covering, and yeah, a lot of functions. So I will load for the modal analysis. I will load project I have created a while ago. We have measured beam. No, sorry, I didn't want to load this. This is an example file which we are deliver with our software, but here you can see real measurements I have done. It's a, let me show it's this geometry. It was an aluminum beam with 14 measurement points, and I want to show you how we can do a modal analysis here. So these are the FRFs I have recorded. If I put them all in this chart, you can see very good the global modes here. First mode, second, third, and fourth. And now I want to run this modal analysis to identify the frequency, the mode shapes, and the damping. I go here and I start with the advanced model end-of analysis tool. And it's very easy to use. So automatically this workspace is selected with these measurements, and in the first step we select the algorithm we want to use. So we have here 3 algorithms, two in the time domain and 1 in the frequency domain. And in this case, I use a polytime plus because we have a very low structural damping with very sharp peaks. And I select the range I want to analyze. So I want to start here and I want to end here. We have here some helping functions to identify how many modes are estimated here in the sections, and we enter, for example, you see this red line with the MIF function, so it drops where probably a mode is. We count this, we enter it here, so 4, and we run the algorithm, the modal algorithm. And now for you can see a stabilization diagram with several iteration steps, and if you see here these icons in one line, this is an indicator that there is a real mode. And our software has an automatic mode selection, so the best modes are selected automatically here in the stabilization diagram. So here you can see directly the selected modes. So this is clear first bending mode. This is a second bending mode. Here we have a torsional mode. And this is a third bending mode. We have here more mode indicator functions. If nothing is red, then your measurement is good. If it's red, then you have to do the measurement again. But in this case, it was a very good measurement, and yeah. But you can also select, of course, the modes manually here if you want, yeah, if it's required. But in this case, it looks very good. And if you can also return, click on return, select another measurement range, select another algorithm, and create a calculation. It's very easy. So now you can save the modes and you will find them in your project, and you can export these modes, and yeah, you can export them, and second. Export them and create a report, create a GIF animation or a video for your presentation. Let me open another project.
But I think we have to come to the end, just to leave some time for questions and answers.
Okay. Yeah. Okay, now we are open for the question and answer part.
So, Syed, you want to do some summary
Yes.
or conclusion?
Yeah. Okay. Yes, please. Please feel free. Do you have any questions? Please. Can forward your questions right now, or maybe you can actually later on you can actually forward to us. Then from there we can actually follow up with Kristen and Arthur as well.
Yeah. So, if you got any questions, just write in
Yeah.
the chat. We like to answer immediately. Give detailed questions. Some questions are simple, some are complex. So the complex ones we can answer later on. But if you now have any questions, please just go to the chat and ask your questions, if any. I think this was a very long presentation, a lot of technical details. Right. So, do we have questions?
Okay, guys. If there's no questions, let's wrap up this webinar. Okay. Thank you, Arthur and Kristen as well. For the introductions and as for the live demonstration as well. So everyone, we hope today's webinar will provide, practical insight into how this powerful combination can enhance your testing capabilities and improve overall measurement performance. Beside that, if you are interested in experiencing the solution firsthand, do email us. We will be happy to arrange a complimentary 30 days trial of the software for your evaluations. So once again, thank you for joining us and have a great day, everyone.
Yeah, thank you very much.
Okay, all right. Thank you, guys.
Thank you
Thank
very
you.
Thank
much.
you. Bye.
You.
Bye bye.
Bye. Bye.